Hello and welcome to another session of Leetcode. Today we're solving perfect squares. And again, this is a classic problem. It's asked by Google and Amazon. It's a fairly new problem, but it's gotten a lot of good ratings. So anyway, yeah, so the problem is given a number n and you have been given a perfect squares and you have to find the least number of perfect squares that add up to that number. So for example, if n is equal to 12, then the output would be 3 because you can use 3 fours to create to add to 12. So in every problem I talk about intuition and I have typed out some stuff already. But yeah, intuition is very important in solving every problem. And it is okay to start with the obvious solution. An obvious solution may not be the right solution, but it's a right place to start. So for example, if I take a number 12 and I start to think about it, if I need to maximize if I need to minimize the number of perfect squares, maybe I should start with the maximum or the greatest perfect square, which is obviously less than n. So let's say I start with 9, so I have 1 9. Now I'm left with 3, and I can make 3 with 3 ones, so the result is 4, which is obviously incorrect. But what we did here is a greedy approach where greedy approach is nothing but you're just maximizing your desired output at every step. But in this case, it may not work. It will not work, obviously. So then we go back to dynamic programming that, okay, how can I create smaller sub-solutions and then create larger solutions from those? So if you look at perfect squares, and if I can generate complements from this perfect square, so for example, for n is equal to 1, I can take 1. For n equal to 2, I can take 2 ones. For n equal to 3, I can take 3 ones. I don't need to scan ahead because the number you're trying to make is less than the next perfect square, so I'm not iterating over it. Now things get interesting when n is equal to 4. So now you have multiple subsolutions. So you start with 1 and you say, okay, I will take 1, and then what I'm left with is 3, and I've already computed 3. So let me start with 1 plus dp of 3, and that results in 4. But I don't stop here because I have to still go forward with the remaining perfect squares as long as they are less than or equal to the number. So I go to the next perfect square, which is 4, and I see, okay, 4 minus 4 is 0, so I take 1 4, and I don't need to have anything else, which is what dp0 signifies, right? So you have two answers here. One is 4 and one is 1. And obviously you have to take minimum of 4 and 1. So the final output for that is 1. So in this dynamic programming problem, you find sub-solutions and then you scan through all the sub-solutions to take the minimum and then assign that value. So now dp of 4 is 1. And you do the same process over and over, and yeah, you build up, basically you build up to whatever n is required in the question. Okay, so let's start coding, and I think things will become more clear as I start coding. And you can take square root to know how many perfect squares you need. And this returns a double, so I'm typecasting this. And then I'm gonna create a squares array, which basically stores my perfect squares. So for example, if n is 9, you only need perfect squares up to uh, 3. Like you only need 3 perfect squares, right? So you need 1, then you need 4, and you need 9. You don't need any more perfect squares than more than the square root of that number. Okay, so this would initialize the squares array, and yeah, okay. Yeah, this looks good. Now let's build our DP solution. Yeah, and before beginning, let's initialize the value. Let's initialize the value with maximum values because we have to pick the minimum later. So you can start with the max, so you can initialize them with the maximum values possible. You can use a arrays.fill, or you can iterate through it. Same thing. Actually, let's start with 0. And you can assign any arbitrary value, which is maximum. I'm assigning I itself because that could be the maximum value, because 1 is a perfect square, so you can use as many ones to create that sum. So the maximum value could be I. Okay, and now let's start building our DP solution. I can start with 2 because I already know 1 is 1. And the second loop is to scan through all the eligible perfect squares. Okay, this should start with 0. And then what I want to do here is I want to compute the minimum. So you're scanning and always comparing. So let's say you take one perfect square, and then you're basically finding the complement of that. So that would be I minus squares of k. So for example, if n is equal to 12, what you're doing is you're comparing in every iteration that, let's take a simpler example. Let's take 4. So for example, if n is equal to 4, then as I explained before, you're iterating through the perfect square. So you will iterate through 2 perfect squares. So you start with 1, and that yielded 1 plus, so that would give you 1 plus dp of 3, which you have already computed. So the result is 4. And then in the next iteration, when k becomes 1, then you are looking at 4. So now you're saying 1, and the complement now is dp of 0, which is 1. And then you're taking the minimum of these two values. So the output would be, so dp of, so the final output is 1, basically. And we also have to have a condition where we do not go past, we do not scan in our perfect squares past the I itself. So if n is equal to 4, you do not want to go past beyond that. yeah, basically this condition shouldn't be negative. So I can say if this is less than 0, then you can break. Okay, this looks good. And finally, we have built up the DP array, and now you have to return the last element. Okay, that works. Yeah, so thank you for watching, and I'll see you in the next video.